Hello, everyone. I am excited to get started with this series on calculus. Um, Main thing I'm going to be doing is just going through some examples and kind of giving some overviews on different things. So without further ado, let's jump into it. Okay. Mhm. All right. We say one of the first ideas in calculus is this idea of a limit. And a limit is really not that difficult an idea. Basically, it's like, for example, if you, and we'll make this little stick figure and we're going to call this guy Bob. Okay. We're got Bob. And Bob is traveling to the Grand Canyon. Okay. So he's at the Grand Canyon. Woo. That's the other side of the canyon. Okay. That's example of my Grand Canyon or whatever. All right. Well, basically, here's what a limit is. If Bob walks in this direction, right, he's getting to the edge of this cliff. Okay. And if he, of course, if he falls down, he'll be down here in what's that river? I guess is the Colorado, right? It goes through the Grand Canyon. Probably embarrassing myself here, but anyway, so Bob here, he's going to be standing on the edge of this cliff. As long as he doesn't actually get, let me use a different color here, but as long as he doesn't actually get to this point here, as long as he's not actually on this point, it looks like he'll basically be up here, right, on this level. Okay. But as soon as he gets here, then he's heading, he's going to be going down, tumbles all the way down, 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 down. Now, the idea of a limit is saying that, hey, Bob can get infinitesimally, he can get really, 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 really close. Get infinitesimally close to this edge without actually going over it. Or, as another example, you can think about what I like to do sometimes. If you take an eraser or something that's not hard or something like that, and you throw it up against the wall. So this is your wall, and this is your projectile, whatever it is. It will get infinitely close to the wall, but it will never actually go through the wall. Like throw a pin against the wall or something like that. It will never actually go through the wall, but then it'll just bounce off. And so the idea of a limit is that you're getting really, 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 really close, but you're never actually going to be at that particular spot. So we're getting really, 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 really close, but we're never actually going to be at that spot. And so that takes us to our formal definition of a limit. The limit as x approaches a, and so whenever you see, I'm also going to recreate it, but so the limit as x approaches a. So this arrow means approaches. Okay. The limit as x approaches a for some function of x is and here's the big part, real number. Your limit has to be a number. It can't be infinity, negative infinity, whatever it is. It has to be a real number. All right. That f of x approaches as x approaches a. If such a number exists, because it doesn't always, if f of x does indeed approach a real number, we denote that number as L for the limit value, and we can say the limit exists, and we write it as such. The limit as x approaches a of f of x is equal to L. or as f of x goes to L, x approaches A or goes to A. What in the world does that mean? Well, basically it's like this. In general, we're talking about a function has two main things we got going on, right? We have a set of inputs, which is usually denoted as, with the x usually denotes our independent variable, and we have a set of outputs where f of x is usually denoted as our dependent variable. All right. So for example, if you had, I don't know, for every cow, you could make 3,000 burgers, right? Well, in that situation, x would represent the amount of cows you have, and f of x would represent your burgers, whatever. Okay. So let's say we have some kind of graph like, I don't know, this. Okay. And let's put some values on it. Let's say this value is 3. Let's use 3 as well. Let's make this 4. I don't know. Let's make this 1 or something. Okay. All right. So basically, what all of this is saying is let's let, A be some just arbitrary input value. Okay. And then let's let f of A be some arbitrary, it doesn't actually have to be 3, just be some arbitrary output. All right. So f of A just means the value at A. So in this case, it's 3, 3 is what I claimed this to be 3, 3 earlier, but you get the idea. All right. Here's the deal. We can say that the limit exists. Okay. So as our function, all right, and we're denoting this as f of x. So as this function is getting closer to A, as a matter of fact, as it's getting closer to A from both sides. Okay. It seems to be going at really, really, really close to this L value. All right. Now, it doesn't really matter what, f of A actually is, but it sure does look like this is getting really, 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 really close to this L value. And so we can say is that the limit as x, so in other words, as your, it's the x value. So x is getting closer to A, x is getting closer to A, either side, right? As you're getting closer to A, this A value, the f of x, in other words, your output, your set of outputs is getting closer to this value, L. Or whatever it is. Well, actually, in this case, it's not going to be coming from the, well, we'll just leave it this way. It's getting closer and closer to L. All right. Now, if I confused you, I'm going to try to do my best to unconfuse you with a couple of examples. All right. So first example says, find the following for this f of x. So we're going to claim this right here to be f of x. All right. So first, we're going to determine the limit as x approaches 2 from the left. So whenever you see this little sign right here, what's the negative? It means from the left. So the way I like to do it is I think about it like this. Imagine Bob is traveling. All right. And he's traveling, he's traveling, he's traveling. Where does it look like he's headed? It doesn't matter where he actually where he gets to at 2, because we're evaluating the limit at 2. So this is our A value, if you will. So what we're saying is the limit as x approaches 2 from the left of f of x is 10, because it looks like as he's getting closer to 10, this is our L value is going to be 10. So as he's getting closer to 2, the y value that he's getting closest to is 10, or the f of x value he's getting closest to is 10. Now from the right, let me use a different color. Here, so as he's approaching from the right, so this way basically, he also looks like he's heading to 10. He's heading to this L value. So 10, boom. And so here's what we can say. If the limit from the left is equal to the limit from the right, so if these two are equal, then we can just say that the limit as f of x as x approaches 2, not necessarily from the left to the right, we just say at 2 is 10. But we can only do that if the limit from the left and right are heading towards a specific number. Not necessarily heading towards infinity, but heading towards a specific number. Oh, last thing. F of 2 is also 10. Right? You can see 210 is a part of the answer choices here. So that's what we have. It's like if you look at A, the answer actually is 10. You know, you plug in 2, you get it out 10. All right, let's take a look at this one. The limit as x approaches -2 from the left. All right, so we're going from the left. Looks like it's actually heading towards 0 from the left. All right. From the right, let's see here. From the right, it looks like it's heading towards 0 again. Remember, it's where it's traveling to, not where it actually ends up. Now, since the limit from the left is equal to the limit from the right, what we can say is the limit at that particular point is then 0, because they're equal. However, this one's different in the fact that f of 2, in other words, we actually evaluated this thing. The actual answer is 1.5, right? Because there's a hole right here at -2. So the actual evaluation of this thing is actually at 1.5. Notice the limit is just talking about what you're getting really, 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 really close to as x approaches something, not necessarily what it actually is at. All right, let's do one more. So in this example, the limit is x approaches from the left. Closer, 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 closer from the left. Looks like it's heading to, this looks like it's about 16. So we got f of x. Ooh, that green. Let's use a different color green, maybe a little darker. There we go. However, as x is approaching 2 from the right, doesn't look like it's headed to 16. It looks like it's heading to 10. Okay. Well, now we've got a limit. The left side does not equal the right side. Therefore, the limit as x approaches 2 of f of x does not exist. But you can see, let's see if we scroll in here a little bit. But you can see there's a hole up here. And then it's filled in down here, which means that the actual value at 2 is down here. It is 10. Yeah, that's it. So I hope this helps. And I'll see you guys in the next one.